Good morning, this is your Stat Sensei, Mr. Spensei, and this is an assignment on errors and power. Just a little multiple choice assignment helping us identify what's going on. So a police officer uses a motion detector to indicate whether a car is traveling faster than the speed limit. A speeding ticket is issued to the driver of the car if the officer believes the driver is speeding, as indicated by the detector. The situation is similar to using a null and alternative hypothesis to decide whether to issue a ticket. The hypothesis can be stated as follows. The driver is not speeding. Remember, court of law, they're innocent unless we find enough evidence. The motion detector says they're speeding. So the driver is speeding would be the alternative. Okay? So which of the following describes power of the test? Well, power is rejecting a false null. Now, I probably ought to have inserted the word correctly. Now, but it's always correct to reject a false null. Power is correctly rejecting a false null. It's doing the right thing. So, if we rejected that the driver is speeding. So we reject this, believe this, and we did the right thing. So the probability of issuing a ticket to a driver who's speeding. Oh, they're speeding. So we rejected that. We believe this. How would we act? We'd issue them a ticket. I like that. This looks pretty good. The probability of issuing a ticket to a driver is not speeding. That's an error. Power is not an error. The probability of not issuing a ticket to a driver who is speeding. If they're speeding, they should be getting a ticket. So that's also an error. Power is doing the right thing. The probability of not issuing to a driver who is not speeding, not an error, but power is we had to reject the null. We had to reject the null. So if they're not speeding, we didn't reject the null. So that's wrong. The probability of the motion detector, that has nothing to do with it. Our best answer choice is A. Same problem. A police officer uses a motion detector, so I'm not going to read this again. It's exactly the same thing. Which of the following probability of a type 2 error? All right, type 2 is a fail to reject. Fail to reject a false null. Or another way is believe the lying HO. All right, so you believe this, but it was a lie. So I believe they're not speeding. So if I believe they're not speeding, I'm not giving them a ticket. The probability of issuing a ticket to is speeding. No, we're not issuing a ticket. Issuing a ticket, not issuing. Um, we are not going to issue because we believe they're not speeding. So it's one of these two. We believe they're not issuing. The probability of not issuing a ticket to a driver who is speeding. That looks pretty good. Let's look at this one. The probability of not issuing a ticket to who is not speeding. This is not an error. This is not an error. And type 2 has to be an error. Not issuing a ticket to someone who's not speeding, they shouldn't be getting a ticket. So my best choice is C. Sticking with the police officer problem. Which of the following describes a type 1? All right. So type 1 is rejecting a false, rejecting a true null by mistake. So I rejected this, but it was actually true. And this is what I believe, and this was false. I rejected that they weren't speeding. Well, so now I believe they are speeding, and if they are speeding, I give them a ticket, but they weren't. This was actually true. They were not speeding. So the probability of issuing a ticket to a driver who is speeding, not an error. That's not an error. That's doing the right thing. They should, if they are speeding, they should get a ticket. Remember, we're looking for an error. The probability of issuing a ticket to is not speeding. Yep, that's it. We're giving them a ticket, but they weren't speeding. So this is my answer for number 3. All right, moving on to number 4. A doctor uses a new diagnostic test to indicate whether a patient has a certain disease. The doctor will prescribe a medication for the patient if the doctor believes the patient has a disease as indicated by the test. The situation is similar to using a null hypothesis as an alternative. So here it is. The patient does not have a disease. The patient does have a disease. What is the probability of a type 1 error? All right. So in this case, a type 1, remember, reject a true null. All right. So I rejected this, but this was true. I believe this. This was false. Well, I believe they do not have the disease. They don't have the disease, but I believe they do. And because they have the do, I'm going to prescribe medication. The probability of the new test is safer. That has nothing to do with it. The probability of the new test indicates the disease in a patient who has the disease. Indicates they have the disease, who has the disease, not an error. We're looking for errors. The probability of a new test indicates the disease in a patient who does not have a disease. Oh, this is an error. We indicated they have the disease, but they don't. That right there is a type 1. We believe they have the disease, but they do not. All right. Same problem, so I'm not going to read it. I'm just going to jump to the question. Which of the following is a type 2? Well, type 2 is fail to reject a false null. Believe the lying HO. All right, believe the lying ho. So, type 2. Once again, this has nothing to do with it. The probability new test indicates the disease in a patient who has the disease. Well, first off, we believe this, but this is false. The probability new test indicates the disease in a patient who has the disease. Well, this is not an error, and we're looking for an error. The probability the new test indicates the disease in a patient who does not have the disease. That's an error, but that's indicating that they have the disease. So that's believing this, and that's a type 1. This is a type 1. We have to believe that they don't have the disease. The new test indicates they do not have the disease. Hey, does not have the disease. We're looking for does not have the disease in a patient who has the disease. That's our type 2. This also says does not have the disease in a patient who does not have the disease. This is not an error. So there's nothing wrong with that. This one's not an error. Number 6. We have the same scenario, so I'm not going to reread it. At a test of significance was run, which resulted in a p-value 0.0031 and compared with an alpha 0.01. What type of error could have been committed? So I have 0.0031. That's my p-value. That's less than 0.01 because 31 is less than 100. So I would have rejected HO. If I reject, the only type of error that I could have committed was a type 1. A type 1 because the p-value was smaller than alpha. Doesn't mean I did commit a type 1, but that is the only type I could have committed. All right, number 7. A doctor uses a new diagnostic test to indicate whether a patient has a certain disease. Oh, same scenario. A test was run at a significance level of 0.01. What type of error? And we have 0.031. So 0.031, and we have 0.01. Well, there's my p-value. This is my alpha. make them the same length. 31 is definitely greater than 10. So I'm going to fail to reject. If I fail to reject, the only type I could have committed is type 2. Fail to type 2. A type 2 error because the p-value was larger than alpha. All right. All right. So a medical doctor uses a diagnostic test to determine whether a patient has arthritis. A treatment will be prescribed only if the doctor thinks the patient has arthritis. The situation is similar to using a null and alternative. Here it is. The null, they do not have arthritis. The patient does have arthritis. Which of the following represents a type 2? All right. Type 2 is a fail to. That means I believe, but this is a lie. I believe, but this is a lie. All right. So in this case, we are going to believe that they do not have arthritis. So diagnosing arthritis, no. So we're going to fail to diagnose arthritis in a patient who has arthritis. Yes, we believe this, but this is the actual truth. This is what's true. We believe this lie. We believe the lying hoe. All right. Number 9. A medical doctor uses a diagnostic test to determine whether, and so the same arthritis problem, which of the following is a type 1? All right, type 1 is reject a true. All right. So in this case, the hoe's telling the truth. All right. So we reject, and this is true. We believe, but this is a lie. So we rejected that. So we believe that they do have arthritis, but they do not. All right. Diagnosing arthritis in a patient who has arthritis. Not an error. We're only looking for errors. Failing to diagnose, no, we didn't fail. We diagnosed arthritis. Diagnosing arthritis in a patient who does not, yes, that's an error. We said that they do have arthritis when in fact they do not. We believe that they do when we rejected this, which was the truth that they don't. All right. Continuing with the arthritis problem. Which of the following is the power of the test? Well, power is rejecting or correctly rejecting a false null. Or another way of saying it is correctly rejecting a lying hoe. So we rejected this. Reject. This was a lie. We reject the lie. We believe this is a true. No error was committed. So in this case, we cannot have made a mistake. We did not commit an error. Diagnosing arthritis. So we rejected this. So we believe this. The patient has arthritis. In a patient who has arthritis, that's power. We did the right thing. Okay. So a statistical test involves the following null and alternative hypothesis. The mean is 64 and the mean and the alternative is it's greater than 64. Well, we're looking for a type 2 error. Type 2 is fail to reject. So I believe, but remember it's an error, so that means I believed the lie. This was true. All right. Failing to reject the null hypothesis when the mean is 64. No. Failing to reject, that's not an error because they're saying when it equals 64, we should fail to reject. Failing to reject the null when the population is greater than 64. Yeah, we failed to reject this. We failed to reject this and when it was greater than 64. A statistical test involves the following known alternative. Same one. Which of the following describes a type 1? All right. Type 1, reject a true null. All right. Well, this is true. Well, we rejected the truth and we believe the lie. So we rejected this and we believe the lie. So we're rejecting. So first off, the failing part goes away. Rejecting the null hypothesis when the mean is 64. Yeah, we rejected it when it actually was the truth. This one, rejecting the null when the population is greater than 64. We should be, in this case, we should be rejecting. This is not an error because you should reject when it's greater than 64. So not an error. All right. Which of the following describes the power of the test? Power is not an error. Power is correctly rejecting or correctly rejecting a lying HO. No error. So failing, nope, we didn't fail anything. We rejected. We rejected the null hypothesis when the mean is 64. Oh, that's an error. We shouldn't reject it if it is 64. So this is an error. Power is not an error. Rejecting the null hypothesis when the population is greater than 64. We should reject this if it's greater than 64. That's power. Power is rejecting when you're supposed to. You did the right thing. You rejected the lying hope. Always a good idea in life. Consider the results of a hypothesis test which indicates there's not enough evidence to reject the null hypothesis. Which of the following statements is about the error is correct? All right, consider the results of a hypothesis which indicates there's not enough evidence to reject the null. All right, so in this case, we have HO and HA. There's not enough evidence, so we fail to reject. All right. A type 1 error, no, because we failed to reject. We didn't have enough evidence. You can only commit a type 1 if you reject. A type 2 error could have been committed, but not a type 1. That's true. If you fail to reject, the only type of error you can make is a type 2. Consider the results of the hypothesis. Which of the following statements about the error is true? All right. There is enough evidence. So HO, HA. In this case, we have enough evidence. So what's our decision? Our decision is to reject. So if we reject, all right, if a type 1 error could have been committed, but not a type 2. And by the way, I probably should have done this on the previous one. We know it's not a type 2. You can never commit both types, all right? You can never commit both types. If there's enough evidence to reject, the only type you could have made is a type 1. If there's not enough evidence, the only type of error that you could have committed, it's a type 2. All right. An environmental scientist wants to test the null hypothesis with an anti-pollution device for cars is not effective. Under which of the following would a type 1 error be committed? All right. Be careful with this. Take the moment. HO, not effective, because that's what they told us the null is, because it could have very easily been the other way around. So you always need to take a moment and define the null and alternative. All right. So not effective device and effective. And the only reason I know that is because they told me that the null is that it's not effective. The sign, so type 1. So I reject this. I reject the truth and I believe the lie. All right. So I'm rejecting this and I'm believing the lie. The scientist concludes the anti-pollution is effective. So I believe this. That's what it says. when it's not. Oh, when that's, yeah, so that's it. That's number 16. Number 17. An environmental scientist wants to test the null hypothesis that an anti-pollution device for cars is not effective. I'm going to write this right here below it because I don't have a room above it. HO, not effective. HA, effective. Once again, read the prompt. This could have very easily been swapped and this would be effective and this not effective. But they said the null hypothesis is that it's not effective. Under which the following conditions would a type 2 error would be committed? So we're looking for type 2 error. Type 2 error is we fail to reject. So we believe, and this is a lie, and this is the truth. All right? So the scientist concludes that the anti-pollution device is effective when it's actually not. No, we believe that it's not effective. The scientist concludes that the anti-device is not effective when this is the truth is that it is effective. All right, so 17 is B. Which of the following is the best interpretation of the power of the test? All right, so once again, um, power is correctly rejecting a false null. So reject correct. First off, you have to reject a false null, and it's correct. And that is correct. So power is the probability of detecting an effect if no effect exists. Detecting an effect, if there isn't one, that's an error. Power is not an error. Power is doing the right thing. Power is the probability of detecting the effect if an effect exists. Hey, you should detect an effect if an effect exists. That's what power is. All right. Detecting an effect if there is an effect. All right. Appreciate you watching. I hope that helps out with errors. Thank you.